Hello friends, greeting from CENTUM Academy. So today I have made a video on JEE Advanced question on differentiability. So as you can see, there is a function on your screen f of x, which is given as x square x minus x square, and there is another function g of x, which is actually a piecewise defined function. So we call such functions as piecewise defined functions, where the value of g of x is the maximum of f of t, where t lies between 0 and x itself is between 0 and 1, and it becomes sine of pi x when x is greater than 1. So now what we need to do in the interval 0 to infinity, we need to check the differentiability of g of x, right? In fact, we need to state whether it is true or false that this function is differentiable everywhere except at x equal to 1, right? Now I've just quickly drawn the graph of the function on the x and the y axis just between 0 to 1. So we all know this parabola y equal to x minus x square is an inverted parabola, and it achieves its maximum value at this point, x equal to half. So basically it's the midway between 0 and 1, and this maximum value will be 1 by 4. Right? Now just focus on this part of the function g of x. Now what do we understand by maximum of f of t when t lies between 0 and x? It simply means that as you are moving on this graph, let's say I start my journey from this point 0. If I move upwards, let's say I move to some different position x, right? Obviously x should be greater than 0. Then the function retains the maximum of the value that the function will have either at this point or at 0. So obviously as I am going up, the maximum value will be at the point which is higher, right? For example, at this point will have a higher value, right? If I go to this point, I will have a higher value at this point. If I go to this point, I will have a higher value at this point. So what is happening? All the while when the function is increasing from 0 to half, the value of the function will be maximum at the higher position as compared to the 0 position, right? So between 0 to half, since the function is increasing, I can say the maximum value of f of t will always be at f of x and not at f of 0, right? Now, what will happen post half? Let's say I start going down right now. Now, when I'm going down, what will happen? The function's value will keep going down. So, but I have to retain the maximum of the value. So, basically, all the while when you are going down, the maximum value of the function will always be at this point, which is 1 by 4. So, what will happen? The function will start behaving as a straight line y equal to 1 by 4 between the interval half to 1, right? So what will happen? The function, I'm just drawing a rough graph, the function will go up like this and then it will stabilize at 1 by 4, right? The moment we reach 1, the function will switch on to sine pi x, and as we know, sine pi x, the graph will appear to be a sinusoidal curve like this, right? So if we see the resultant of these two factors on GeoGebra, the graph will appear to be like this. So as you can see, the function is increasing. The moment it reaches half, x equal to half, the function stops at 1 by 4 value. So at this junction, the function stops at this value, which is 1 by 4. So this value is 1 by 4. And as we proceed till 1, it continues with that value, and thereafter the function follows the graph of the sine function, that is sine of pi x, right? As you can clearly see, the function shows discontinuity at this junction, right? So there is a jump discontinuity at this junction, and hence the function will not be differentiable at x equal to 1. Therefore, when it says that it is differentiable everywhere except at x equal to 1, So we can see in the entire interval from 0 to infinity, the function will be differentiable because it is not showing any kind of a corner or a discontinuity except at this very point, and hence the statement is actually true because it says it is differentiable everywhere except for 1. So basically your answer will be true. Thank you so much for watching.